And as I do that, I'll come over here, I guess, and I get 3x minus 5 equals 12. And now we're kind of into that standard setup here. Do I need to get rid of the 3 from the x side or the minus 5 from the x's side? Got to do the minus 5 first, so I'll add 5 to both sides. So plus 5 to both sides gives me 3x equals 17. And finally, I divide by 3 on both sides. Did you guys also get, like me, 17 thirds? Yes. Okay. I was going to say, sometimes a number like that makes you feel like you definitely did something wrong. Right? It makes you question a little bit. It's okay. 17 thirds is still a number. It's all good. All right. Do you guys have any questions you'd like to talk about? Anything at all on number 1? All right. So then number 2. This is also a solve, but this time it's an inequality, and so we would end up typically graphing the solution of this as well. So what would you guys suggest as a first step? I think there's one of 2 ways you could go, and it doesn't really matter which way you go. What do you think, Joe? Okay, fair enough. So let's distribute the minus 5. So when you do that, you get negative 5x plus 15 is less than 10. So you might have done it a different way. Joe's suggestion is good, so we'll stick with that. If we go this way, what would be your second step?
Minus the 15.
Subtract the 15. We're trying to isolate that x. So we subtract 15 from both sides. So I get negative 5x, and I get negative 5. This is an important step. Do I need to flip the inequality? Because I did just subtract from both sides, right?
No.
Why don't I flip the inequality? It's when you divide or multiply. Yeah, it's not when you just subtract. So then it still is less than. What's my final step, though?
Divide by negative 5.
So this is where we flip the inequality. So I divide both sides by negative 5. This would give me x is greater than 1. That inequality got flipped when I divided both sides by a negative. All right, so then I got to graph this, and I need to put either a closed circle or an open circle on 1. Which one is it? It's open, and the arrow goes which direction? To the right, because we're talking about numbers that are bigger than 1, greater than 1. So we go arrow to the right. All right, so a few little tricky steps in there to deal with. Hopefully they went well. Do you have any questions? Remember, asking a question is not an admission that you missed it or anything like that. It just means sometimes people get it right, but they still have a question. That's okay. Anything I can do to help? All right. So then number 3, going back to graphing. So number 3, it's been a little while. Hopefully this went well for you. Did you guys graph it directly from this form, or did you change it to a different form? Changed it. Which form did you change it to? Slope-intercept. So if I want to put this in a slope-intercept form, what would be another way to think about getting to that form? What do I need to do? Subtract 5x. Okay. What's the goal? Why would I even care about subtracting 5x? Say again? Get y by itself. That's right. So I end up with negative 2y equals negative 12 minus 5x. And then I got to get rid of the minus 2, of course, to get the y by itself, so I divide. So dividing by negative 2 on all 3 terms, I end up with positive y equals positive 6 plus 5 over 2x. So there's a lot of minus signs in there. Just remember, a negative divided by a negative is a positive, and that'll get you to this form. Okay, so from there, this is all well and good. I got this into that slope-intercept form. Let's remind ourselves that we're going to graph an equation of a line or write the equation of the line. I got to have 2 things. What are the 2 things I got to have? Point and slope. Okay, so I should be able to figure out a point and a slope from this. What's the slope of this line? 5 over 2. And what point is on the line? 0, 6, I think, right? 0, 6. I had to look because sometimes my 6's end up looking like 5s and vice versa. And then I almost wrote a 5. Okay, there we go. So 0, 6 is my point, so I'll start off by plotting that. 1, 2, 3, 4, 5, there's 6. And then my slope is 5 over 2. There's not really room to go up there, is there? So I'm actually going to go down 5, left 2. So down 1, 2, 3, 4, 5, left 2. I get in a lovely line that looks about like that. Put arrows on the end. And there you go. Hey, just a reminder, there's been a couple of folks that as you've been doing WebAssigns have had a question about this. Do you remember if you try to graph a line on WebAssign, if you plot some points, like you literally like put a point on the graph and a point on the graph and you connect it with the line, a lot of times WebAssign doesn't like that. And then if you remove the points and just leave the line itself, WebAssign does like that. It's a little weird. Basically, they're just saying, hey, it should be a line, not a line plus a couple of points that are on the line. They just want to see the line. And I agree, it's a little bit weird. I would never mark that wrong on our quiz or test. But if you want to get the little green check on WebAssign, just be aware that could be the issue if it's giving you the red X. Okay. Lastly, it says solve the system of equations. You can see we've got two lovely equations in terms of X and Y. We have a number of methods. We could do graphing, we could do elimination, we could do substitution. Which way did you choose? Substitution, elimination. I think either one of those is perfectly good here. Ben said let's do elimination or substitution, so let's do that. It's fine. If I was going to do substitution, we should get the same answer either way. I'm going to solve for y, so this would be y equals negative 4x minus 15. So what I can do is in the other equation, I can replace the y with what the y equals. So in the other equation, for the other equation, I'm going to write 2x plus 3y equals 5. But notice I have removed the y from the equation, and the only thing I can put in its place is what the y actually equals. So that would be negative 4x minus 15. All right, so then with substitution, almost always there's going to be a distributive property. So I distribute the 3. And I get 2x minus 12x minus 45 equals 5. Do a little cleaning up here. I get negative 10x minus 45 equals 5. And now I just solve. So adding 45 to both sides, I end up with negative 10x is equal to 50. Therefore, when I divide by negative 10, I get x is equal to negative 5. So no matter what method you use, do we all agree that x is negative 5? Yes. Okay, that's good. And then the nice thing about substitution is your plug back in is set up very nicely. Plug back in is right up here. So I know that y equals negative 4x minus 15. So y equals negative 4 times negative 5 minus 15. That's 20 minus 15. So that's y equals 5. So my final answer, I will just write over here, is negative 5 comma 5. Okay, so again, no matter what method you used, we should all get the same answer. So we agree on that? Is that good? Okay. You could always check it by plugging back into both. And to be honest with you, whenever I write a test question or a quiz question like this, and I want to make sure that I got the answer right and it all makes sense, I just plug it back in. And if it works in both, I'm good. And if it doesn't, then somewhere I made a mistake. I'll go back and fix it. All right, so that's all the DMR for today. One last chance for any questions on any of that. Be happy to answer for you. All right, excuse me. Okay, so the other thing you have in front of you there, root 12 is really square root of 2 times 3. Square root of 3, like I said, 3 is already prime, so there's not really anything we would do there. Minus the square root of 27. Well, 27 is really 3 times 3 times 3. And then you try to simplify your radicals. So did you notice, I'm sure you did, that in the first one there's 2 2's. And in the third one there's 2 3's. So 2 2's inside the radical simplify to be a single 2 outside, right? So that would be 2 root 3. The root 3 still just is what it is. And then in the last one, 2 3's on the inside means single 3 on the outside. So minus 3 root 3. What's the coefficient on this one in the middle? It's really a 1. So 2 root 3 plus 1 root 3 minus, they're all root 3's, aren't they? So they actually were like radicals. So 2 root 3 plus 1 root 3, you add the coefficients, you get 3 root 3 minus 3 root 3. 3 minus 3, again, we're adding the coefficients, you get 0 root 3. Now let's remember that 0 root 3 is really 0 times root 3, which is just 0. Does that make sense?
Yeah. I think it's just that I got confused because, like, it wasn't what the video was saying. So,
No, it was, though. The issue is, again, don't take this as like I'm blaming you or something. The issue is you didn't really make the connection between the stuff we'd been doing.
yes. Class in the video.
Exactly, right. So the issue there, and I'm always going to, like, forever, I'm going to always try to break down your walls. The walls of, Mr. Anderson, we covered that on Monday, and now it's Wednesday. And I say that tongue-in-cheek because, believe me or not, people from freshman age, like you guys, all the way up to like senior age, they do the same thing. They want to say, Mr. Anderson, that was last chapter. And you expect me to remember that? I'm like,
Yeah.
yes, I do, actually. So, again, not in like a judgmental way, like what's wrong with you. But, yeah, just try to make those connections and look at that and say, whoa, root 12. I think I might have done one like that before. That's actually 2 root 3. And, oh, my gosh, look, they're actually alike. Just investigating a little bit deeper. So, yeah. You bet. Any other questions on that one? Okay, fair enough. So let's do this. Let's do a little bit of work here. And I think we just have a handful of examples. Bless you. And I imagine what we've just done and what you saw in the video, I think will really help you with these first two. So if you guys would, let's do that. If you guys would flip over, and I want you guys to try numbers 1 and 2 and see how it all goes. Check some answers. Do some Q&A here in just a few minutes. Obviously, number 1 at first glance, kind of like number 2, you look at it and you're like, your immediate reaction is probably, those radicals are different, therefore I can't add them, right? But we want to investigate a little bit further because it could be that they could be simplified and then added. I think with number 1, you find out that in the end is actually not true because according to your factor tree, you probably saw that 10 is just 2 times 5. And 6 is 2 times 3. At this point, you probably noticed that there's no pair of 2s, there's no pair of 5s, there's no pair of 3s. So those radicals cannot be simplified any further than they already are. And so because of that, root 10 plus root 6 would be as simple as this gets. In other words, it's already been simplified. And so you can't do anything further. So you might look at that number 1 and make a bad conclusion about number 2, right? You could look at number 2 and say, oh, number 2 is just like number 1. The radicals are different. Therefore, we can't simplify. But you always want to investigate and break things down before you make that judgment. The 54 can be broken down quite a bit. 54 would be 3 3s and a 2, I think, on the prime factor. So 3 times 3 times 3 times 2. And the 24, I think, would be 3 2s and a 3. And you see that on this one, unlike number 1, you actually can do a little simplifying because over here there's a pair of 3s that could come out. Over here there's a pair of 2s that could come out. So the root 54 is really 3 times the square root of 3 times 2. And the root 24 is really 2 times the square root of 2 times 3. And of course, 3 times 2 and 2 times 3 are both 6. So you get 3 root 6 plus 2 root 6. And now we have to kind of reevaluate and ask ourselves, wait a minute, are they really like radicals?
They are.
They really are. We just didn't know it at first because we didn't have them simplified. So 3 root 6 plus 2 root 6. This will be directly from the video at this point. We treat the root 6 as almost like an x, like a variable, and we just add the coefficients. So 3 plus 2, of course, is 5. I end up with 5 root 6. 5 root 6 for a final value there. So questions or concerns about numbers 1 or 2? They're similar but very different in the end. Okay, if you haven't already moved on to numbers 3 or 4, please do. This will be it for our examples here in class. Well for you, or it's finishing up well. Okay, guys, number 3, let's check answers.
14c minus 6 square root c.
Was 147 a little weird?
Yeah, it was a
little strange. It ends up being 7 times 7 times 3 times t times t. And then over here, the 48 is 4 2s and a 3. Like so. So at first glance, these don't look like they're like radicals at all, right? They don't even look close. I think we'll find out in the end they are like radicals. I've got a pair of 7s and a pair of t's. So that's going to come out as 7t times the square root of the one left over, 3. Right? So 7t root 3. Over here, the t is where it is. It's not going anywhere. But there's a pair of 2's and then another pair of 2's, right? So those 2 2's and those other 2 2's would come out as a 2 and a 2. And I'm left with the one left over on the inside. And it's at this point you look at the radicals and you're like, those actually are like radicals, right? They're both root 3's. You clean up the one on the right a little bit, 7t root 3 plus 4t root 3. And you realize that not only are they like radicals, the variables are the same too. So they're both t root 3 terms. And since they're both t root 3 terms, they are like terms, can be added. 7 plus 4 is 11. So it'd be 11t root 3 for your final expression. Saw a lot of those as I was walking around. Certainly encouraged by that. Do you have any questions at all about number 3? Okay. So then number 4. Number 4 has some simpler stuff, but there's a lot more of them. And so certainly seems like there's a lot. So the first one is we've got 9 root c squared. So maybe you realize that that c squared is not prime, right? It's c times c. So we'll deal with that here in a second. Then I've got minus 12 root c plus 8 root c plus 5c. And then the one that I saw the most where people maybe forgot to do something with that they should have done something with it is the last one. Isn't 4 2 times 2? 4 is not prime, so we could break it down into being 2 times 2. So based on this, would you guys agree with me that the 3 middle radicals are as simplified as they're going to get as far as the radicals themselves?
Yeah.
But the 2 on the ends, we can simplify them a little bit. So for the first one, I've got a pair of c's, and 2 c's in the radical come out as just a single c. So that would be 9c. What's left over in the radical?
Nothing.
Technically a 1, but the square root of 1 is just 1. So the radical is done essentially, right? We've done what the radical told us to do. So there's nothing left in there. There's no more radical. And then I've got minus 12 root c plus 8 root c plus 5c minus, you probably noticed the pair of 2's, right? So there's 2 2's, which come out as a single 2, so that would be minus 2 root c. I'm ready to add everything up here, but before I do you have any questions on the 2 simplifyings that I've done? Okay, so then what's like what? What is like 9c? 5c. Yep, that's old school. That's from way back in like September, I think. So 9c and 5c. When I add those up, what do I get? 14c is right. And then, is there anything like the minus 12c? Oh, 12 root c. The 8 root c, yeah, everything else. All 3 of those other terms are like each other. So I'm just going to add up my coefficients. Negative 12 plus 8 is negative 4, plus negative 2 is negative 6. So negative 6 root c would be my final expression. Okay, so that last page, numbers 3 and 4, a little tougher than the first page. You guys have any questions at all? Okay, let's head to the board. I'd like to do a little practicing with you. So let's get these 2 tables here, Victoria's table, Coy's table. Head on up to the board. We'll just check this out real quick before we go. Please use both boards. Give yourself plenty of room. We'll switch here in a second.
I did the 4. I did the 4 math problem.
I'm having to go downstairs.
Okay, go for it. Okay, try it. Ready, go.